Remember, in sequences, there is a pattern. Let's say 1, 3, 5, 7, 9. What is the next number?
11.
11. So what is common? How do we recognize the pattern?
It's addition of 2, or it's every odd number.
Well, in sequences, we take common difference. 2, 2, 2, 2, 2
Yeah.
throughout. So first difference is common. This relation is called linear relation, or
Linear.
we call it as linear sequence. Linear sequence is the same as arithmetic sequence. So if I ask you, in this sequence, what is the, let's say, 100th term? How do we find that?
I forgot. It's like the original plus the difference times 100 minus 1.
Okay.
Or something. It's like a formula.
Yeah. So basically, sequence, arithmetic sequence can be represented as A1, A2, A3, so on. Let's say common difference is D.
Yeah.
We know that from A1 to A2, we'll do plus D, like this, right? So if you are talking about, let's say, A2, it will be A1 plus
D.
1D. A3?
Yeah. A1 plus 2D.
A1 plus 2D. So similarly, if I talk about AN, A1 plus
Plus D times AN minus 1.
it's N minus 1.
Oh, yeah. That's what I meant.
Yeah. So I was asking about 100th term. Can you guess? In that sequence,
It would be 1 plus 99 times 2. So 199.
okay? So this is how we find the nth term. Okay. This formula can be modified also as an is equal to, let's say, kth term, ak plus n minus k into d. It's like in this formula, you are adding the first term with n minus 1 into d.
Yeah.
But what if you start from kth term? If you are starting from, let's say, kth term, it will be n minus k into d. If k is equal to 1, it becomes the same formula, n minus 1 into d. Okay. So these two formulas are important. That's it. And you also know that relation is linear, right?
Yeah.
So it's a straight line relation.
Yeah.
So that's about arithmetic sequence. Let's talk about GP, geometric progression or sequence. G, geometric sequence. Geometric sequence means, let's say I consider a sequence 1, 2, 4, 8. Next one will be
16.
16. After that will be
32.
32. So what do they all have in common?
They're all being multiplied by 2 from the previous number.
Yeah. Instead of, so if you pass one by one, instead of addition, it is multiplication. So either by 2, or if I consider another sequence 128, 64, 32, 16, next one will be
8.
8, right? So In this case, when you are passing 1 by 1, you are multiplying with,
You're dividing by 1/2.
or multiplication with half. Dividing by 2, multiplying with half. Correct?
Yeah.
So these types of sequences, when multiplication is involved, is called geometric progression. When the successive terms are related by a common number. This half is called common ratio. So this ratio is common throughout. For the above sequence, common ratio is half. For this sequence, common ratio is
For which one?
this above one.
Oh, the common ratio is 1/2.
This one, this.
And then one above it is 2.
Yeah. So common ratio can be obtained by ratio of successive terms. Is it first one by next one or next one by before one?
Next one by before one.
Yes. Common ratio, usually represented as small r, is equal to, can I write an nth term upon a?
The first, or the n minus 1.
N minus 1. Nth term upon the previous one is called common ratio, not an minus 1 upon an. So these are some basics. So if we talk about nth term, an, right, is equal to an minus 1 into r. From here, we can obtain. So an minus 1 into r power 1. So in general, if you are talking about nth term, the formula is a n minus k r power
1.
If you are talking about k, it is k.
Oh, yeah.
So if k is 1, okay, let's say if k is n minus 1, k is n minus 1, an will be,
And will be a to the minus 1.
see, n minus of k, right?
Yeah.
Like this, n minus of n minus 1, r power n minus 1.
R to the power n minus 1.
So these numbers are actually subscript. You know what that is?
Yeah.
So it's like a1 means first day, a2 means second day. So don't confuse a2 with 2a, not like that. Okay.
Yeah.
N minus n minus 1 means
Oh, it's the first term.
a1 into r power n minus 1.
Yeah.
So this formula and this formula are extremely important. So these two formulas for geometric sequence, and in arithmetic sequence also we talked about two formulas, this and this, in terms of k and in terms of first term. Any doubt so far?
No.
Okay, let's review some basic concepts. Let's say if I write 0, 1, 2, 3, 4, so on up to 100. How many numbers are there? How many terms?
100. Or 101.
100 is not. 101. So when you are counting by 0, you have to add 1. So usually it's like number of terms is equal to last minus first plus 1. So last minus first, 100 minus 0 plus 1. So this is when common difference is 1. So when you are counting natural numbers 1, 2, 3, 4, so on 100, how many will be there?
100.
100. So 100 minus 1 plus 1. Okay. 100 terms. It's like, if you remember the formula previously, we are talking about arithmetic sequence. An is equal to a1
plus a plus n minus 1 times d.
n minus 1 into d, right? Number of terms means what variable here?
N minus 1.
See, n is the number of terms. N is the term. So it's like, if you solve for n, it will be an minus a1 is equal to n minus 1 into d. So if you divide by d plus 1, this will be n. So you see this last minus first upon common difference plus 1. Is it clear?
Yeah.
So it's just that in the earlier case, when we are counting 1 to 100, the common difference is 1. So we just write simply last minus first plus 1. So the actual formula is last minus first upon common difference plus 1. Not
Yeah.
last minus 1, last minus first plus 1 upon d. These two are different things. I think you know the difference, right? Between these two, this one and this one. Did you notice?
That the 1 is on top of the numerator.
Yeah. So you have to add 1 at the end after dividing by d. That gives us the right answer. We know that arithmetic sequences is nothing but they follow a linear relation. So if you talk about change in arithmetic rate of change in arithmetic sequence, what will be the answer? Rate of change will be
It'll be constant.
constant throughout. Yeah, and there are some things to consider. Let's say we consider the previous example 1, 3, 5, 7, 9. A1 is this, A2 is 3, A4, A5. Okay.
Yeah.
If you plot it on the graph, let's say A1, A2, third term, fourth term, fifth term. If you plot it, the follows.
Yeah, so then it'll be a straight line,
Yes.
right?
Yes, straight line. Yeah. So 1, 1.
And then 2, 3.
2, 3. So something like this. Straight line, they all. Okay. Notice one thing. This sequence is not continuous. That means,
So it stops.
yes, this is called discrete. That means we are having gaps in between. So domain and range are discrete. It means that one value, one value, one value. They are not connected like this. They are not continuous. Discrete means not continuous. Continuous function means, you know, right? Continuous means if you draw the graph, you should not lift the pen. Continuous. Not lift the pen when drawing. Discontinuous means you might have to lift the pen like this, but it is still, parts of it is continuous. So this is not this is discontinuous but not discrete. This is discontinuous but not discrete. Okay.
Yeah.
Yeah. So domain and range are discrete. So when we are talking about exponential functions, I mean geometric sequences, I kind of revealed the answer.
Yeah.
What relation is that?
For which one?
Geometric sequence.
Oh, yeah.
You continuously scroll down. Okay.
Is it exponential?
Exponential. But domain and range are
Like whether it's continuous or discontinuous?
they are not continuous. They are still discrete.
Discontinuous. Oh, discrete, yeah.
So it's like 1, 2, 4, 8, 16. Let's say first term A1, A2, A3, A4, A5. 1, 2, 3, 4, 5. So A1 will be 1, 1. Second point will be 2,
2,
2.
2. And then 3, 4.
3, 4. And then
4,
0 will be
8,
perfect.
5.
So usually its nature will be something like this exponential graph,
Yeah.
but it's not continuous.
What?
It is not continuous. It's not like this.
Yeah.
We don't draw like this. We draw plots, points like this. Nature is exponential,
Yeah.
but discrete. So this is about 2.2 change in linear and exponential function. And let's say if they give you a table, xy table like this, some random values. How do you check if the graph is linear? How do you know if the graph is quadratic? How do you know if it is cubic? And how do you know if it is exponential?
You look at like the gaps in between and then the like difference.
Now, first thing is, the very important thing is,
Yeah.
regarding x, you have to arrange them in either ascending order or descending order.
Yeah.
AO, ascending order or descending order. And ensure that equal space intervals, x values. Is this clear? Ensure that gaps will be same.
Equal x values. Like the gaps between the x values.
Yeah. Then you can take first difference. Okay.
Yeah.
With y we take difference. I mean, to determine if it is linear, quadratic, cubic, we take first difference. For linear, quadratic, cubic, we take differences. So if first difference is constant, it is linear. But if second difference is constant, quadratic. But if third difference is constant, it is cubic. Clear?
So
Yeah.
what's the difference between cubic and linear?
See, cubic means, see if you remember the relation between linear and quadratic.
Yeah.
Linear means first difference is constant.
Yeah.
So it's like the values are like this. When you take these two values, let's say they differ by common number, 2, 2, 2. This will be linear.
Yeah.
But if it is not 2, 2, 2, let's say if you get the first difference is delta y values are 1, 2, 3. This delta y of delta y, I mean difference of first difference, is 1, right?
Yeah.
This is constant. So It is what relation?
Cubic?
Quadratic. See, we are doing second
Oh,
difference, right? See, it is a name. Quadratic means second difference, constant. Linear means
okay.
first difference, constant. Cubic means third difference, constant. Okay, I think that is clear.
Yeah.
Okay, so I'm just writing the symbols. Delta 2y means second difference of y. Delta means change, so delta 2 means second difference. It's kind of improvised. Yeah, ensure that equal space intervals. Okay, so composite function is also part of chapter 2. So let's, I think it is 2.2.7, composition of function, a composite function. So let's say f of x is given as, let's say, x squared plus 5x plus 6. G of x is equal to 2 root x plus 1. Actually, this is part of your homework. Like, I have sent you homework, right? That one. So
From
find,
last week?
yeah, huh? Previous class homework. F of g of x and g of f of x. Right?
I put it in parentheses.
Yes, you have to put parentheses.
So it's like you're squaring all of it. And then that simplifies to 4 times x plus 1.
Yeah.
Yeah. And then plus 6. And then it becomes 4 times x plus 1 plus 10 times x plus 1 plus 6. And then finally, it's just 4x plus 10 root x plus 1 plus 16.
Plus 10.
Oh,
4
yeah.
plus 6, 10.
6 equals 10, yeah.
So this is f of g. G of f.
So then for g of f, you take f of x and you put it into g. So it becomes 2 times the root of x squared plus 5x plus 7.
That's, okay. Can you find the domain for this?
Yeah, 1 second. Isn't it all real numbers?
Yeah, because
Or wait, it's, yeah, because it'll never be negative.
yeah, d less than 0, correct?
Yeah.
And a is positive. So overall value will be,
Positive.
yeah. So x squared plus 5x plus 7. A is positive and d negative means positive value. So x domain is all clear. What about the range now?
The range,
Yeah,
isn't it just y is greater than or equal to 0?
yeah, that's it. I mean, if you try to solve it for try to solve it analytically, so you have to convert them into perfect square.
Yeah.
x plus 5 by 2 whole square plus 7 minus 25 by 4. Okay, let's move on to the next page. I'll write it in the next page. I was saying that, so x plus 5 by 2 whole square plus 7 minus 25 by 4. So this will be whole square plus 3 upon 4. Do you understand why this?
Yeah.
Half of middle term. So x 5 by 2 and then 5 by 2 square you have to balance. You have to subtract in order to make the balance.
Yeah.
So 3 by 4, right? So this inside the bracket and inside the square root value is greater than or equal to 3 by 4.
Yeah.
Minimum value of this quadratic is greater than or equal to 3 by 4. Since there was a square root, so range will be 2 times square root of something greater than or equal to 4. So it's like 2 into a number which is greater than or equal to root 3 by 8.
Yeah.
So range will be greater than or equal to
Root 3.
multiplying by 2, right? So 2, fine, right? So range is not like greater than or equal to 0. It's just that inside this thing, it has certain values. So minimum value of this quadratic is 3 by 4. So it cannot be like numbers like 0.5. It cannot be 0.5. So that is why we write like this. Next is, yeah, let's do one more question regarding differences. So let's say x and y table is given, values are given. Okay, so 1, 3, 4, 5. What type of relation is f of x?
So first you have to look for the gaps between the x, right? Or does that not matter? Okay, so the gaps are, the first one is 2 and the second one is 1. So if the gap, and then it's 1, and then it's 2, and then it's 1 again.
So gaps are not even throughout. So with x, when we are talking about x, gaps are not evenly spaced. So try to understand this. So what we are going to do is consider only those which are evenly spaced.
So between 3, 4, and 5. Oh, 3, 4, 5. Yeah, that's it.
3, 4, and 5, or
7 and 8.
1 to 3, 3 to 5, 5 to 7. Which ones are evenly spaced? So 1 to 3, 3 to 5, 5 to 7. So if you are considering this, you can say 1, 3, 5. We consider only these three things. Or if you consider the interval 3, 4, and 5. So 3, 4, 5. That is also fine. So it's just that when you are considering 1, 3, and 5, you have to ignore
The 7 and, oh wait, the 4, the 7, and 8.
yeah. So we modify this table into 3, 4, 5 table, or we modify that into 1, 3, 5, 7. Yeah, there's also 7 here. 1, 3, 5, and 7.
Yeah.
So this is like more, right? More values of x. 1, 3, 5, 7. So we consider the corresponding outputs, y values. For 1 it is
83.
Yeah, 83, 3,
89.
5 is
94. And then 101.
hmm. So the question is still the same. What is the relation? How do we determine that?
So now you look at like the gaps between the y.
Yeah.
So from 83 to 89, it's a gap of 6. From 89 to 95, it's a gap of 6. And then 95 to 101, it's a gap of 6. So it's a quadratic.
So
Because
delta y
the
is
second. Yeah.
So
Wait, so is it quadratic or is it cubic?
see how many times
So
you have done the difference?
Oh, only once.
Once. So linear. Once is constant means linear.
Yeah.
Okay.
Yeah.
And if you want to check for 3, 4, and 5, it will be
89, 4 is 92, and then 5 is 95, and then the gap is 3 for all of them. So it's linear.
linear. So notice one thing. When the gap is 1, difference was 3. And the gap is 2,
The gap was 6.
difference is 6.
Yeah, difference.
So it is a linear function. So it's not always taking a difference of y, whatever they give. We have to arrange it in a proper order. Ascending to descending, descending to ascending, and make sure that evenly spaced. This is the significance. Okay.
Yeah.
Usually most of the questions, some questions, they automatically arrange everything and give it to the student. So student may not realize that, but the real concept is this. This is the concept.
Yeah.
Composition. So in between there is modeling. I told you that I will be covering modeling later. Modeling is same thing only. It's like using the calculator.
Modeling? Is that what's
Function
modeling
modeling.
for?
Yes. What? So to determine f of x is a function or not, we use vertical line test. So we draw a vertical line in the graph and see if at any point it is meeting more than one point. If it is meeting more, then it is not a function.
And what's the horizontal line test for?
Horizontal line test is for one functions. To determine if it is a one function.
And 1-to-1 means like every x value has its own like y value.
Yeah. Every x value is corresponding only with one y value. It's not like two x values correspond to the same value. It's not like this. Like this. Or
Yeah.
like this. So for every one value input, for every one input in domain corresponds to exactly one output in range. That is what it means by one function. So inverse exists. This is important concept. Inverse exists only for one function.
1-to-1 function.
Yeah. So let us talk about exponential graph. Let's say y is equal to something, a power x. Find its inverse function.
So you would switch the x and y, so it would be x equal to a to the power y, and then you would take the logarithm something.
So log x is equal to,
Like you would take log.
yeah, on both sides.
Yeah.
So log x is equal to,
Wait, it's log x. Oh,
log of this, log of this, right?
okay, yeah.
A power y means logarithm. Okay, logarithms done.
Yeah.
So it's like log of a power m will be same as,
Log of a power m would be equal. Wait, how would you do that? Because there's.
this m, we have a property. It jumps here.
Oh, it would be m times log a.
So what about this now?
So then that one would become y log a.
Yeah. See, when I write nothing, what does this mean actually?
It's base 10.
Base 10, automatically assumption. If I write ln means,
Then it's natural log and like the base is e.
yeah, base is equal to e. E value, you know,
It's like 2.71.
yeah, 2.71. It's a transcendental number. So yeah, so log x is equal to y into log a. Correct. So y will be equal to,
So y would be equal to log x over log a.
this will be equal to,
Log base a x.
x to the base a. So notice something.
Oh yeah.
So this is my new y. So this is my f inverse of x. Okay. So
Yeah.
notice something. F of x was exponential. F inverse x is,
A logarithmic.
so logarithmic and exponential are inverses of each other.
Yeah. And then square root and oh wait. So what's square root in the inverse of?
Square and square root are inverses of each other.
Oh yeah.
Okay. So if f of x is square function, parabola, it will be square root. So it's like, and one thing we need to keep in mind is, let's say quadratic is something like this, y equal to x square. What will be the inverse?
You would take this one would just be the square root, so it would be y is equal to root x.
F inverse x is equal to root x. But before we do that, we have to first, what do we need to consider?
You need to the domain. Wait, yeah, it's the domain, right?
Yeah, we need to consider the domain in which function is 1 1. 1 1 functions have inverse. So if you look at this parabola, here to here it is acting like 1 1, and here to here it is also acting like 1 1.
Yeah.
But overall as the function, it is not 1 1 because it fails horizontal line test. So function is acting as 1 1, in specific
So
interval.
it would be,
Yeah.
so the inverse would be root x only for x is greater than or equal to 0.
Yeah, if you look carefully, y is equal to x square, right?
Yeah.
X is equal to y square is inverse relation. And if you look carefully, y is equal to
Root x or root plus or minus x.
plus or minus
Yeah, x, root
root
x.
x. Yeah, root x. So
Yeah.
there are two values actually. What does that mean is, see, if we have considered these two intervals, right? So one inverse exists for this to this. Another inverse exists for this to this.
Yeah.
So that is why we get two values. So splitting the domain is important. So in which interval it is acting like 1 1. So less than 0 and greater than 0. Any doubt?
No.
So for we have to consider two intervals, x less than 0, x greater than 0, like this, x greater than or equal to 0. So can you guess which of this exists for this interval and for this interval?
That's for the first interval, it's going to be y is equal to negative root x. Yeah. And then for the second interval, it's going to be for y is equal to positive root x.
Okay. Yeah. And
Yeah.
one more thing is regarding inverse functions, domain and range. Domain of f is same as
Yeah.
dash of f inverse. What is it?
The range.
Range. Range of f inverse. Same. Range of f is same as,
The domain of f inverse.
yes, domain of f inverse. So can I also say domain of f inverse is same as
The range of the function.
range of f? Okay.
Yeah.
And range of f inverse is same as
The domain of
f,
of f.
like that. So in this, if you are considering, look at this parabola. I told you that we need to consider specific intervals, correct? This and this.
Yeah.
Let us study the first one. This is, what is the domain of this function?
X is less than 0.
Yeah, this is domain of f. So range of f inverse will be
X is less than 0.
x is less than.
Oh wait, yeah.
Yeah, range of f inverse means domain of f.
Yeah.
So range of f inverse. So we have like root x, y equal to minus root x. So which range out of these two, which of the following has range?
Y is equal to negative root x.
Yeah. So range means it's like y less than 0. Negative root x corresponds to this, and this automatically corresponds to this. Okay. And now?
No.
See, when we are talking about range means we automatically assume y values, right? So that is why
Yeah.
I have written y there. No confusion?
No.
Yeah, let me check next topic. So these are the basics of inverse functions. So square root, cube root, exponential, logarithmic are inverse of each other.
Yeah.
What is the composition of, scroll down, what is the composition of f and f inverse?
It's always equal to just x.
X. Yeah, so basically f and f inverse are actually symmetric about
The
y equal to x log. So if you consider this part of the parabola, y equal to x line will be something like 45-degree line. Right out?
yeah. No.
So the inverse of this function will be symmetric. You have to draw it. Can you draw it?
So it'll be
Yeah. And do you remember square root of x graph will be how?
like it goes from the origin and then goes up and like that.
Yeah. Well, right here. Yeah. So we know that square and square root are inverses. So let's say if I consider square function, if I try to draw the
Oh yeah.
inverse, it will be symmetric about this one. So that is why we get the graph as here to here equal to like this, and then it'll go like this. Make sense? So that is a confirmation that inverse and original function are symmetric about y equal to x
No.
one. And regarding logarithms, do you know the basic formulas?
Yeah. Like log x. Oh, 0. Wait. Yeah,
Something
0.
0, right?
Yeah.
So if I
And
write
then like
is equal to b, how can you convert this into exponent form? This is logarithm form.
yeah, a to the power b equals x.
So it's exponential. So corresponding exponential form is a power
A to the power
b, right?
yeah equals x.
X. So usually in the textbooks they'll say like log n base a. Log n base a is equal to b. So a to the power b is equal to n, or n is equal to a to the power b. Same thing. Next, addition of logarithms, log a plus log b.
It equals log a times b.
A into b. So one thing we need to be careful is same base. So can I write like this? M. Here also it should be not m but m.
Yeah. And then log a of m minus log b of m equals log a over b of
It's
m.
not like a of m. It's like we pronounce it a base m. Log
Oh,
a
am of base
m.
m
What?
minus log b of base m equals log a over b over m. I mean of m.
Base
Base
m.
m. Yeah.
Yeah. Okay. Yeah. And what about log of a power m base m?
Equals m times log n a of base n.
Okay. So if you look carefully, negative of this means if you are trying to prove this, so this is log a base m plus
Log b base m.
negative 1 goes to the exponent b inverse.
Yeah.
Yeah. So it's like addition means a into b inverse means a by b.
Yeah.
Well, that is one way to look at it. And what about log a base n?
It equals 1.
1. And let's say if I write log n base a is equal to b, or is equal to, let's say, log x base a is equal to f of x. What is the domain and what is the range?
The domain would be x is greater than or equal to, no, x is greater than 0.
X is greater than 0, positive numbers, correct?
Yeah. And
Is that all?
then
There is one more condition.
it can't be 1.
Base cannot be 1.
Yeah. And then the range would just be all real numbers. Would it be? Yeah, so y is greater than or equal to 0. Or, yeah.
For this, it is greater than or equal to 0. Here it is, the coefficient is 1, right? Not many. Yeah. So let us do one question and we'll wrap up. So let's say there is an expression x square minus 5x plus 6 x minus 2. This is greater than or equal to 0. Find the solution.
Log base x minus 2 of x minus 3 plus log x minus 2 base x minus 2. And then it's greater than or equal to 0. And then the log x minus 2 base x minus 2 becomes 1. So then it simplifies to log x minus 3 base x minus 2 is greater than or equal to negative 1.
Yeah, me too.
Yeah, and then do you change the base then?
Well, see, whenever a question comes, we put some conditions on that. We assume automatically that this number will be positive. We put a restriction on that. Will be positive, correct?
Yeah.
And regarding the base, it should be?
It has to be greater than 1. Well, it has to be greater than 0 and it can't be 1.
And cannot be 1.
Yeah.
So if you solve this, x square minus 5x plus 6 greater than 0 means x lies between.
For the base?
Yes, we are still solving for x. We need to make sure that.
Yeah, so x is 2, like the critical points
2 and 3
are 2 and 3. So then it starts with plus and then it stays plus.
even multiplicity or odd multiplicity?
For x, oh, yeah.
x3, it is even or odd?
Odd. So then it changes to minus. And then it's odd again, so it changes to plus.
So these are the regions.
So when x is less than 2 and x is greater than 3.
X is greater than 2. Yeah, x is less than 2 and then x is greater than 3. And also, we need to impose the condition that this should follow. X minus 2 is positive. That means what?
Yeah.
X is greater than 2. So
Yeah.
we're also saying that this region we have to done. and x minus 2 is not 1, means x is not equal to
1. So x cannot be 3.
3. So in this, you have to make sure that x cannot be 3. So at 3, there is a hollow circle. So overall common region is this yellow region.
Yeah, x is greater than 3.
X is greater than 3 is the domain. So when you are assuming that x is greater than 3, this x minus 2 will be
Will be positive?
positive. So we are taking positive.
Yeah.
So now what? How do you solve this?
So for now we know which parts are positive.
See, so far we have found domain. Now that
Yeah.
we have found the domain, now we have restricted the x values. We need to solve this directly.
Yeah.
So how
Do
do
we
you solve
change the
that?
base?
What?
We can rewrite it as x minus 3 is greater than or equal to x minus 2 to the power minus 1.
Correct.
So it becomes x minus 3 is greater than or equal to 1 over x minus 2. And then you subtract
Then no need to
1
subtract
minus
actually.
2.
If you look carefully, its value will be positive, right?
Yeah.
So why not just multiply both sides? Inequality sign will
Oh,
not
yeah.
change.
So then you get x minus 2 times x minus 3 is greater than
Yeah.
1.
Yeah. So x square minus cos x minus plus 6 greater than or equal to 1.
And then you subtract the 1, and then you can just do like
Hmm.
find the factors and put it on the number line and everything.
Yeah. So the roots are critical points are roots, right? Minus b plus or minus 25 minus 20.
Yeah.
5. 5 plus root 5 upon 2. So 5 plus root 5 upon 2, 5 minus root 5 upon 2.
Yeah.
So greater than or equal to 0 means which points we need to consider?
If it's greater than 2, then it has to, like, this one.
Yeah, these are the values of x, right?
Yeah.
See, based on this condition alone, these are the points. First, I have plotted them, the roots. And so greater than or equal to 0 means what is the favorable interval?
If it's greater than the root.
Can you simplify how much is this?
What?
Simplify how much is that value? 5 plus root 5 or 5 minus root 5 value means what? Root 5 is
Like what
2
the
power
number
root
is? Yeah, so it becomes like minus 3 over 2. Or, yeah, plus.
Exact value. Put it in the calculator. It should be 1 point something.
5 minus root 5.
Total divided by 2.
It's 1.38.
Yeah, so 1.38, right? So this is like
Yeah.
1.38 is here. And what about this?
5 plus root 5 divided by 2 is equal to 3.6.
This is 3.6. Okay. So greater than or equal to 0 means like this.
Yeah.
So this region and this region. Also, now what? What is the final answer?
That x is greater than 5 plus 5 plus root 5 over 2, and x is less than 5 plus 5 minus root 5 over 2.
Yeah. That is, I have highlighted here only. Blue line.
Yeah.
Also, in the according to the previous condition, x should be
Positive.
like what we just solved. It should be the domain that we obtained greater than
2 or greater than 3.
3, right? Also, x should be x greater than 2. Right out. So 2
Yeah.
lies somewhere around here, correct?
Yeah, so it's only x is greater than 5 plus root 5 over 2.
Yeah. So between yellow and blue, common region is this. Blue is the winner. So the answer. So the value of x is like greater than or equal to or greater than just. Which one is it? Is it
It's
like this?
greater than or equal to.
And why is that? Which one is this? Out of these two, which one is correct?
This one. Because when it's equal to it, it's equal to 0.
See, we don't care about that actually. If you look carefully,
Oh, and it's this one.
this one, right? This one is the. From here, we have obtained that.
Yeah.
So 0 should be included. So this is the right answer. This is not. Okay.
Yeah.
Well, it's a bit complex, but I try to explain everything at once. So this covers like at least 40% syllabus. If you exclude modeling also, it will be like 70 to 80%. I mean, whatever I've explained, how are concepts interconnected, exponential and